Alright, so this is solutions for the 1-4 through 1-6 study guide for your test, and I'm just going to work through every problem for you. If you need to pause as we go, feel free to do that, and rework the problems, make sure you got everything right. But I'll try to go step by step on each one of these so you can see exactly what it is you need to do. Alright, number 1, 3x over x minus 5. And so here we're asked to find the inverse of this function. So remember, f of x is the same thing as y. So this is really the same thing as y equals 3x over x minus 5. And so what we want to do, anytime we find an inverse, we switch x and y. This one's got two x's, but that's okay. So we'll switch x and y, and then we'll solve for y. So we'll put a note over here. Switch x and y, and then solve for y. So here I've switched x and y. This is a little bit of a harder solve than what a normal linear equation would be. So what we're going to do, since I have a fraction and I've got more than one variable in here, I'm going to set this side over 1 to make it a fraction, and I'm going to cross multiply. Okay, so I get x times y minus 5 equals 1 times 3y. When I distribute here, I get x times y minus 5x equals 3y. So now, because y is the variable that I'm trying to solve for, I'm going to get those together on the same side, and I'm going to get everything else away from them. So I'm going to move the 5x, and I'm going to move the 3y. So subtract 3y on both sides, at the same time adding 5x. And so I have xy minus 3y. My 5x's cancel, my 3y's cancel on this side, and I'm left with 5x, okay? So now I would imagine you could probably get to this point, and then you might be a little bit stumped as to how to solve, because I've got two y's and I've got a variable in the coefficient, but that is okay. What I want to do when this situation happens is I want to factor the y out, okay? So just take it out of both terms, and it leaves me with x minus 3. Now, because this is in parentheses, so if I just divide by this entire set of parentheses, which is fine, you can absolutely do that, what I do is I end up with 5x over x minus 3. So it looks very similar to what I started with, excuse me, but there's my inverse, okay? So switch x and y and solve for y. Again, that one's a little bit of a harder solve, but that's okay. All right, number 2. Number 2 is another inverse, and I have 1 minus the square root of x plus 2. So same steps here, switch your x and your y and solve for y. So I don't have a y, but I do have an f of x, so that's the same thing. So I'll just switch these around. And now I'll get y by itself. So remember your order of operations. I'm going in the backwards order of operations here because I am solving and not simplifying. So what I want to do is subtract the 1 from both sides. Okay, so I get x minus 1 equals negative, and remember to keep that negative. That's going to be very important in just a minute. Okay. Square root of y plus 2. So now what I want to do is get rid of that negative, and so the only way really to get rid of that negative is to divide both sides by -1 or multiply both sides by -1. And so essentially what it's going to do, it's going to get rid of this negative here, and it's just, this is a multiply by the way, it's just going to change all these signs on this side. So I end up with negative x plus 1. Okay, again, my goal here is to get y by itself, and if I'm moving too fast, feel free to pause in between steps or rewind or whatever it is you need to do. So here what I want to do now is square both sides. This is not about your ability to expand the expression, but rather to get y, or the equation, but rather to get y by itself. So don't worry about foiling this left side out. Just leave it written exactly this way as you solve, because we're just looking for a general equation in the end. We're not looking, again, this is not about can you FOIL this binomial out. This is about can you solve for y. So now I just want to move this 2 over. And because I've got this parentheses here, I can't combine that 2 with it. So what I'm going to do is just leave it as negative x plus 1 squared minus 2. And there is my inverse equation for number 2. All right, moving right along. Number 3, a little bit different. I tried to give you one of each kind here. Cube root of x minus 1. Cube root of x minus 1. All right, so again, switch x and y. So I've got x equals the cube root of y minus 1. And so to get x by itself, I need to first, or to get y by itself, excuse me, I need to first get rid of this radical, so I'm going to raise both sides to 3. I get x cubed equals y minus 1. Oh, I wrote plus. My brain's getting ahead of my hand here, because what I need to do is add 1 to both sides here to get y by itself. And again, these are not like terms. I can't combine it with the x cubed, so I just leave it written as x cubed plus 1 equals y. So for numbers 4 and 5, I want to pull this sheet up for you so that you can see. What I'm looking for is I'm trying to answer 3 questions here. Is the graph a function? Is the inverse of the graph a function? And is the graph 1-to-1? So let's look at the first one. The first one is a nice little cubic graph that looks like this. So the first question is this a function? And so if you think back, to determine if it's a function or not, we have to determine if every input has one and only one output. Another way we look at that, especially when we look at graphs, is we talk about a vertical line test, okay? Is there any way, any place where you could drop a vertical line and it would intersect the graph more than one time? If it ever hits more than once, then it fails that test. So for this one, we're good, right? There is no place that a vertical line would ever touch the graph more than one time. So we say, yes, this is a function. And the reason is a function. This is a function. And the reason is because it passes the vertical line test. Now for part B, it asks us if the inverse is a function. And so this one's a little bit different, because if you think about, remember, on the first part, we were switching x and y. We were switching x and y for the inverse. So here, if I think about things switched around, instead of a vertical line, I'm thinking about a horizontal line. And if you look, I could draw a horizontal line right here, and all of a sudden this horizontal line is going to hit 3 places. That means it fails that horizontal line test, okay? So what I say is no, the inverse is not a function. And the reason is because it fails not the vertical line test, but the horizontal line test. Okay? And then part C asks us, is it 1-to-1? To be 1-to-1 for what we're talking about, I would need the answer to A and B to both be yes. So no, because it fails horizontal line test. So it would need to pass both to be that 1-to-1 that we're looking for right now. All right. Next one up, we have, looks like a parabola on its side. And same questions here. So is this a function? For part A, this absolutely is a function, because again, if you are, I'm going with inverse, I'm sorry y'all, this absolutely is not a function, because just like the other one, if you drop this vertical line, okay, This time, well, my pen is, if you drop this vertical line, it'll touch more than one time. So no, this one is not a function. It fails, well, the vertical line test. Okay. However, if I look at the inverse, and I'm thinking about a horizontal line, it would definitely pass. So yes, the inverse is a function because it passes the horizontal line test, okay? So remember, vertical line test is to test functionality. Horizontal line test will test the functionality of the inverse. And then for part C, if I get a yes for both, then this is yes. But you see I get a no for the first one. So no, this is not one-to-one because it fails that vertical line test. Okay? Moving right along. So number 6 through 9 ask us to state all of the transformations as well as the parent function. So I have 3 times the absolute value of x plus 5. Oh, sorry. Minus 7. Okay. So here, this is the parent graph is one of those 12 parent functions that we talked about, that we took the test on previously. So here I'm looking, the parent is going to be the absolute value of x. Okay, so now I want to know all the transformations. What all is happening to this function that's causing it to transform from the parent graph? And so if you look, all of these different things are causing it to transform. So this is where you'll use your little cheat sheet, your little third page sheet that lists all your transformations. And we'll just go through listing them out. I think we'll just start from the left since that's the easiest here. This is in front of the whole equation, so it is definitely a vertical stretch or shrink. Vertical is what it is. Since it's bigger than 1, it's going to be a vertical stretch of 3. Again, because it's in front of the whole equation. Difference is if it looked this way, that would be a horizontal. But because it's in front of those absolute value signs, that tells me it's vertical, okay? The 5, again, that's hooked to x. That's inside. It's different than the negative 7 that's on the outside. So that's going to be horizontal. It's a horizontal translation. Remember, everything x is kind of wonky. It goes the opposite way of what you think. So I'm adding it, but it's actually going left. 5. Again, that little half sheet that you have will really help you, or third sheet will really help you identify these transformations and what the function is doing at this point. All right, finally, the negative 7 on the outside, because that's on the outside of the actual function, that is going to be a vertical shift down because it's negative. I'm saying a vertical shift down. I could say a translation down. Either one of those are synonymous there. Down 7 from where it started. Okay? You're not asked to graph these. You're just asked to identify these transformations. All right. For the next one, we have negative x cubed over 2 plus 4. One thing I'll tell you about this one is the divided by 2 is really, I can rewrite that as negative 1/2 x cubed plus 4. So be very careful of that as you analyze these. All right, so here my parent is x to the 3rd. And so now let's identify these transformations. I can see several of them. I've got the 1/2. That negative does something completely different, so make sure you do that as a separate transformation. And then I've got the 4. All right, so the negative out front is going to be my reflection. The question is it a reflection over x or y? And because it's in front of everything and there are no parentheses grouping it or anything like that, it's going to be a reflection over x. My 1/2, again, it's not hooked to x. this way. Instead, it's in front. So this is going to be a vertical shrink of 1/2. And then the 4 on the very end is going to translate up 4. All right, next one. 5 minus square root of 2x minus 3. Again, you have to really be aware of the way the equation is written and know that you can rearrange it to help you understand the function a little bit better. So in other words, this one I could really rewrite as negative square root, and I'm doing two things here at one time. This is 2/3, and then I'm going to put the x here. So you see that this is really a shrink or a stretch being applied to that x. And then this 5 is positive, so I'm going to put it on the end. And now it's a little bit easier to see that that 5 is actually a vertical transformation, and this 2/3 is that stretch or shrink on x. So as we go through that, be very careful. All right. So what I have here are 3 things impacting my transformations. I have this negative sign in front, I have this 2/3, and I have this positive 5. So let's see what everything does. The negative is out front. The negative again indicates a reflection, and because it is done to the entire equation, it's a reflection over x. The 2/3, this time it is in the parentheses here with x, so it's not out front of everything. So that is going to be a horizontal. And remember, everything horizontal is the opposite of what you think. This is smaller, so it's actually going to be a stretch. So we got a horizontal stretch of, and here's where things get a little bit confusing, okay? Because my stretch factor is 2/3 here, what I do, and if you look on that chart that I gave you, it says to take x and divide it by a, right? So if we divide it by 2/3, that's the same thing as multiplying by 3/2. So we say the factor is actually the flip of it, the 3/2. All right, I'm not so worried. I really want you just to recognize that this is a stretch, okay? And then we're going to translate up 5. And I think I forgot to give you the parent here. The parent graph, because you do need to be able to identify that, is going to be the square root of x. All right, moving along. The next one, negative 4x squared. Where was that parentheses around the whole thing? Minus 3. Just make sure I wrote this one right. Negative 4x squared minus 3, yeah. All right, so again, my parent here is going to be x squared. I'm looking, I have a negative, I have a 4, and I have a negative 3. The negative is my reflection. This time it is in parentheses, and it's not outside the whole thing, so this is going to be a reflection over y. My 4, again, is hooked to x, so it's going to be a horizontal. Everything opposite with x, so it's not, even though 4 is bigger than 1, it's going to be a shrink. And again, since it's horizontal, what I'll need to do is flip that. Instead of 4, I'm going to call it 1/4. And then I move down 3, from the 3 there on the end. Okay? All right, next up is when we actually need to write the equations. So let me see if I can get my pen here so I can actually annotate on the, yeah. All right, so several things happening here. I start with x squared, write 1, reflect across x, and a vertical shrink of 1/3, okay? Reflecting across x, remember that's where we're going to make, we're going to put the negative in front of the entire equation. Vertical shrink also goes in front of the entire equation. And then write 1, that's going to be just hooked to x, right? So the right one, I'm going to start out this way. That'll move me right one. Reflect across x means my negative needs to be in front of the whole equation, but I also need a 1/3 out here because that is going to vertically shrink my entire equation there. Okay. For number 11, I start out with, and I'm going to come up here so I have a little more room. I start out with a reflect across the y-axis, which means I'm going to negate x. Okay, so I'm going to put that negative with the x here. And actually, I need to leave a little bit more room because that'll reflect across y, but I also need a horizontal stretch by 5/3. Now, this is where that flipping comes back in because everything is opposite with x, right? So I need this to be 3/5 times x. And now I need to go, so that takes care of this one. Now I need to go up 1, so that goes on the outside since it's a vertical. And there's my equation. All right, number 12, and I'll come over here on this side to do number 12. I start out with x cubed. And I'm going to go, let me look at all my a lot of times it's easier to look at your horizontal stuff first. So I've got a horizontal shrink of 3/4. Okay. So again, I'm going to need to flip that over, right? So instead of 3/4, I'm going to go 4/3 x to the thirds. That will give me a horizontal shrink. I need to go, I shouldn't have done that so fast, left 2. So that, again, that's going to be horizontal, so it's going to need to be hooked to the x. If I go x, I add. If I go left, I add. All right, all that is hooked to x inside there, and then I need to go down 1, which means put that -1 right there on the end of the equation. All right, number 13. Let's see what we got horizontal. We got a horizontal stretch of 3, and then the reflect across the y-axis, that's going to have me to negate my x. So what I want to do, I'm starting with the absolute value of x, horizontal stretch of 3, again flip it, because everything is opposite, right? But then it says it's also got to be across the y-axis, so I need to negate my x. Put us an absolute value, and now also a vertical stretch of 2. So the vertical goes in front. Come on. So it would be a 2 out front here to handle that. So this is number 13. All right. So you're just going to kind of got to reason your way through those, and you'll want to start with those horizontals that way so that you can see. All right, let's move on. All right, so the next set of problems here give us an f of x, square root of x, a g of x, and then it asks us to do some operations here with each one. All right, so the first one says f of g of x. Blue is not a very good color, is it? F of g of x looks something like this. So if you recall, remember I told you there's different ways to write composition, which is what this is. This is the same thing as f of g of x. Okay. So what I want to do is I want to take g of x, which is x squared minus 4, and that is going in for the x in f. So I have the square root of x squared minus 4. All right, but that's not all it asks us to do. It also asks us to look at the domain restrictions here. So I want to take just a minute. Remember, at the domains individually first. So the domain for this one has no restrictions, right? That's negative infinity to infinity. I'm looking for square roots and I'm looking for fractions, and that has neither. This one, however, does have a square root, which means I need to make sure that whatever is under this radical stays positive. So here, my domain needs to make sure that x is greater than or equal to 0. So essentially that's going to mean it's going to start at 0 and go to infinity. Okay. Now, as I look at my composed functions or my combined functions here, I need to make sure that it meets these criteria as well as the criteria for this. So in other words, now x squared minus 4 needs to be bigger than 0. X squared needs to be bigger than 0. Oh, 4, I'm sorry. Which means that x needs to be bigger than or equal to plus or minus 2. Now, when I say plus or minus 2, if you think about that number line, negative 2 is here, positive 2 is here. If it's got to be bigger than, I can ignore this one because it's got to satisfy both parts of that. All right, so I know I got to be bigger than 0 because that comes from this first one. But again, if I have to be bigger than 2, that's really not even important. So my domain here is that I need to be bigger than 2. So my domain is going to be from 2 up to infinity. Okay. 15 flips things around and asks me to do g of f of x. And so this time I'm going to take g and I'm going to plug in the square root of x. So it's the square root of x squared minus 4. So I get these canceled because they're opposites, x minus 4. And so again, look at your domain restrictions. There are no restrictions on this one, no restrictions on this one. This is the only one with restrictions, but because I used it here, I have to include those restrictions in my domain. So from 0. All right. Number 16 multiplies the two together. Okay, so clearly I forgot to hit record as I work these two out, so let me just talk you through them real quick. As I multiply these two, there's no sense in writing them out, so I just leave them like this. And my domain remains the same. There's nothing new there that I need to account for, no new radicals and no new fractions. However, whenever I divide them this way, f divided by g, this is the next problem on the review, I end up with a fraction, and I really have to take into account that the bottom of this fraction, it can't equal 0. All right, so if I solve that, I see that x can't be negative 2 or positive 2. And so if you think about it on a number line, if I'm bigger than 0 already, this is negative 2 way over here, so it's not going to impact what I already have, but 2 is here. So I need to leave that out of my domain, and I do that with those back-to-back parentheses connected with that u. Okay? All right, let's move on. The next ones are graphing ones. And so what I want to do here, let me see if I can get a little better view for you. And this is the last set. All right, so I want to start with the parent graph, and then I want to do each transformation, and I'll finish out with the last one in red, okay? So the first thing I'm going to do is I am going to graph the parent, which is the absolute value of x, right? So if you think back to absolute value, that's 0, 0, 1, 1, 2, 2, and so it's a line in both directions, but everything's got to stay positive. Okay, now, next thing you need to do is your horizontal shrinks or stretches. So this is the same thing as 1/2 x plus 1, just like we talked about at the beginning. So if you use your little half sheet, your little cheat sheet, you'll see that whenever I have a horizontal stretch or shrink, what that does is that takes, and maybe I should pull up your sheet for you so that you can see here. All right, if you look, if I have, I'm sorry, this stays written over it, but I am looking at my horizontal here. right? So it says take every x and divide it by that a that's in front. And that a we have is 1/2. Now, and then y stays the same. So I want you to think about something for just a minute. If I am dividing by a fraction, right? So if I took the x and divided it by a half, dividing by a fraction is the same thing as multiplying by the reciprocal. So really, what I have is I'm going to take every x and multiply it by 2 because I don't want to divide it by a half, right? And then I'll keep y the same. So I had 0, 0. That stays 0, 0. But my 1, 1 becomes 2, 1 because I need to multiply it. If I took 1 divided by a half, that is the same thing as 1 times 2 over 1, okay, which is 2. And then, of course, my negative 1, 1 would become negative 2, 1. So this new graph is going to be 1, 2, 1, and you can see it start to stretch out here. Right? Which is what it should do. A horizontal here stretch of 1/2, right? All right. And now what I want to do is do my very last transformation, which is up 1, excuse me. So every point that I just stretched is going to go up 1, and then up 1. So my graph in red is my final transformed graph. All right, number 19. I'm going to start with that square root graph, which has 0, 0, 1, 1, 1, 2, 3, 4, 2, and kind of looks like half of a parabola on its side. First thing I am going to do is I'm going to reflect it, okay, and because it's here, it's going to reflect over y. So that just means take all these points and flip them over the y-axis. And then what I'm going to do is I'm going to take this graph and move it all down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. Okay, final transformed graph there. All right, number 20. Start with the square root graph. Okay, that's my quadratic. 1, 1, negative 1, 1, 2, 4, and negative 2, 4. Right, so look at what I'm doing. You want to do your shrinks or stretches first. I have a vertical stretch of 2. So if you look back at your cheat sheet there, that means take every x, y. You're going to keep x the same, but you are going to multiply every y by that a. So my 1, 1 becomes 1, 2. My negative 1, 1 becomes negative 1, 2. And my other points are going to go off a little bit, so I'm going to just start with that. So 1, 2, negative 1, 2. And that does look like a vertical stretch, because if I stretch that vertical axis out, it would make that graph get skinnier. And now I want to go to the right 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And the red one is my final transformed. All right, and finally we have the x cubed graph, which the parent, again, that 1, 1, negative 1, 1, and you could actually go out to 8 too. I don't think I have room to do that here, but that's okay. We'll just kind of sketch it here. This is negative 1/2 x cubed. All right, and because the negative here is out front, I'm going to reflect over x, right? Because this is out front of the whole function. It's not hooked in parentheses or anything. So I'm going to reflect over x, which means I'm going to go to, actually, let's do the transformation first, because I did tell you to do that. Let's do the horizontal transformation of 1/2. Again, this looks almost exactly like number 18. So every x is going to be doubled. So 1, 1 is going to become 2, 1. And -1, -1 is going to become -2, -1. Okay, so here and here. So it's a horizontal stretch, it's getting wider. And now I'll take care of that reflection over x. So it will be down here. That 0, 0 is just staying the same each time. And here. So it looks something like this now. Okay? Well, I will end the video if I can get my pen to start working.